Hey guys, today we're going to be talking about and working with polynomials and trying to factor polynomials. It still has everything to do with the concept of figuring out where something crosses the x-axis, like we did in chapter 4. Figuring out where something is equal to 0, that's really what we're after. To do that with something as big as an x cubed or x to the 4th equation, we have to have ways to break it apart. The way we break polynomials apart is by factoring. In the last chapter we learned that x squared plus 4x minus 5 could be written as x plus 5 and x minus 1. And the reason we wanted to do that was to say that x crossed the x-axis at negative 5 and at positive 1, the opposite of what we have with x. That being said, when it's x cubed and x to the 4th, this process becomes much more involved and much more challenging. So today we're going to talk about different approaches and how to identify when we have a special pattern that we can work with. Okay, so it's all about pattern recognition and trying to come up with the best options we have. So we're going to just go through, we're going to go through quite a few examples, and that's how we're going to do this notes video. And then I'll do homework help as well. But honestly, we have to see a lot of them. And so that's how we're going to start this assignment here. On first example, it's called a common monomial. That means there's something in common. And if there's ever a common dividing piece, we always want to pull that out. If you look at this first term, it's x cubed, then I've got x squared, then I've got x. All three of those terms have an x involved. So I can pull an x out and leave a single parenthesis behind. If you take an x out of x cubed, you should have x squared left. If you take an x out of 2x squared, you should have 2x. Notice the exponent is dropping each time. And instead of having negative 15x, it's just minus 15. Now the reason pulling out that common factor, that x, is so helpful is now we have a quadratic, something that we should know how to factor. And that's why when we factor it even further, we get x and x. And how do we split a 15 so it subtracts to make 2? That would be 5 and 3. Because the 15 is negative, my signs have to be different. To get a positive 2, I would do plus 5 minus 3. And so we can see that by pulling that first x out, the problem became factorable, where before it just simply wasn't. Let's keep going from there. Oops. Let me get rid of all that. All right. Part B. Okay. When we have part B, we look, there's a y to the 5th, a y to the 3rd, and a y to the 3rd. Sorry, there's just the two. A y to the 5th and a y to the 3rd. But also the 18 and the 2, those both divide by 2. So I'm going to pull out a 2, a y, and when I decide the exponent of the y, we always take the smallest exponent listed. Since I have a y cubed, I'll pull a y cubed. If you try to pull y to the 5th or y to the 4th, our second term doesn't have enough there. So if I pull a 2 out and a y to the 3rd, this first term would still have y squared left. And the 18, instead of being minus 18, it would be minus 9. And since I took all of the y cubed, that would be the end of that problem. Except that y squared minus 9 still factors further. Remember, we have these difference squares. And so y squared minus 9 would split as y and y. Then 9 splits as 3 and 3 with a plus or a minus. And then this last one is more of the same. We see that there's a 4 in all of these numbers. And z squared, z cubed, z to the 4th, z cubed, and z squared. We could pull a 4z squared out, leaving us with z to the 2nd minus 4z plus 4. And that again factors z and z. What are the factors of 4 that add up to 4? It would be 2 and 2. and the signs have to match because I've got a positive 4 at the end, but a negative 4 in the middle tells me to go minus and minus. 4z squared times z minus 2 times z minus 2. So those are examples of how we pull common terms out first, the GCF. And so we're going to see some of those to begin with, like here. If we go through this guided practice in an example right here, okay, if you look at number 1 right here, we notice they all have an x in common. So if I pull that x out, that would leave me with x squared minus 7x plus 10. And then I may or may not be able to factor this. It depends on that 10. But if I pull out an x and an x, the factors of 10 that add up to 7 would be 5 and 2. And because the 10's positive, my signs have to match. To get a negative 7, I go minus and minus. All right? So that's the standard factor by pulling out a common term and then seeing what's left behind. But there are some special cases that we need to talk about, some special rules. And they fit into these two categories. I'm not going to make you memorize this, although in college algebra or pre-calculus the answer is yes, you should memorize these. But it's called the sum of cubes and the difference of cubes. Okay? The key idea here is that you have to have something cubed plus something cubed, and that's all that's in the equation, or something cubed minus something cubed. So if we look here at part A in example 2, we have x cubed plus 64. If we can find a number that cubed equals 64, we can do a sum of cubes. Okay, so we see this is cubed there. The 64, if we look at the numbers that you multiply 3 times to get 64, we end up with 4. This is really important because that tells me that my A is x and my B is going to be 4 because it's 4 cubed. That will allow me to write x plus 4, I'm following the pattern, times a squared would be x squared minus x times 4 is 4x plus, and b squared, b being 4, would be 16. Now some of you are going to want to try and factor this right-hand side, or this right-hand parenthesis, but a sum of cubes or a difference of cubes does not factor beyond this. The remainder of the problem will be filled with imaginary values, which we don't find by factoring. We'd find that using like the quadratic formula or something like that. The same process holds true for the difference of cubes. The key issue is making sure that you know what A is and what B is before you start. All right, let's look at our next type of example. Sometimes we end up with problems where there are 4 terms in the equation. And when we see that 4 terms in the equations, our next approach is going to be to use what's called factor by grouping. Okay? To factor by grouping, we are going to throw a set of parentheses around the first 2 terms, and we're going to throw a set of parentheses around the second 2 terms. Now this is really important. Whatever this sign is in the middle, it's attached to that number after it. So if it's a positive 16, I need the positive to stay with the 16, especially when it's negative. That negative has to stay with the 16 or this won't work. I'm now going to just look for what's common. What does x cubed and 3x squared have in common? Well, they both have an x squared. So in this parentheses, if I pull out an x squared, I would have x and minus 3. In the second parentheses, what do these have in common? Well, 16 and 48 both divide by 16. And whatever this sign is right there, I'm going to use it. So I'm going to pull a negative 16 out, and that will leave me with a positive x, but the 48 divided by a negative 16 should come out negative 3. Now you should be able to see that our 2 parentheses match, and that's perfect because that means that I can put my outside together as x squared minus 16, and I can put the inside as a single parentheses. Now, some of you are going to say, why did we not have x minus 3 twice, right? It's like, I see it twice, why is it not twice in the problem? The reason why has to do with FOIL. if you remember that FOIL would take the first term times both of these, right? And then take the second term times both of these. You can think of it this way. The first term times the whole parentheses, the second term times the whole parentheses. This is the same thing as FOIL, so I can just rewrite it this way and it has the equivalence. Because we see x squared minus 16, and that is a difference of squares, we are going to go a step further. A lot of the problems will, a lot of the problems will stop. So we end up with x minus 4 and x plus 4. But then, of course, we also have our x minus 3. So that's called factor by grouping. We're getting close. I know the video is going on a little long, but we've only got one more type, I think, that we have to deal with. And then it's just about finding things that are of that consistent pattern. Okay? There's two different ones I want to look at here. We're going to look at A and we're going to look at B. These problems have what's called a quadratic form. Yeah. Okay, so this first one, it's not quadratic, but it has a quadratic pattern to it. 16x to the fourth minus 81. This should look a lot like a difference of squares, except that that's a fourth power. It's not an x squared. It's okay. We're going to treat it much like we would a quadratic. You know, it's a difference of squares. We'd use 4x and 4x. The 81 we'd split as 9 and 9. And of course, because it's a difference of squares, we have a plus and a minus. This doesn't quite work because 4x times 4x is only 16x squared. But to make it work, all we have to do is throw a square here and a square here, and now we've balanced the x to the fourth into two squares, and we go from there. A lot of times this is where we stop, but occasionally we end up with something like this. That looks again like a difference of squares, which means we're going to factor a second time. 2x and 2x plus 3 and minus 3. And of course 4x squared plus 9, because it's addition, it doesn't reduce, it doesn't factor. And so that's how we would end up looking in that problem. Part B, you know, it has that common 2p squared. All I really want to focus on is this part here. So let's take p to the sixth plus 5p to the third plus 6. Okay, ask yourself this question. Is the first exponent double the middle exponent? Yes. Just like x squared plus 5x, you know, to the first. The first exponent is double the first one. And so that means this has this quadratic pattern. And so I can treat it just like a regular factoring problem, but instead of using p and p, I'm going to use half of that 6 and go p cubed and p cubed. Then I split the 6. How do you split a 6 so that it adds up to 5? Well, that'd be 2 and 3. Because the 6 is positive, signs have to match, and to get a positive 5, we go plus plus. That's how we factor something that's in this, what we call quadratic form. Hopefully this will help you get an understanding of the different approaches to factoring. There's a lot there, and until you get time with them, it's just not much you can do. If you need help, reach out. Say, I don't understand this. Can we do more example problems? And work together through this so that you can be successful. Good luck, and we'll see you in class.